Hi, welcome to my calculus lesson. Today we'll be talking about optimization. So I have one example here. Suppose a farmer has a large piece of land and he wants to make a rectangular fence for his animals. But he has no more money to buy more wood for the fence. Therefore, the total length of the fence is fixed to be P equals 250 meters. What should be the width and length of the rectangle such that the area is maximized? So first, let's analyze this question. It's telling us that we want to maximize the area. So that in my brain, that's telling me that the area equation for this rectangle would be our primary and our secondary would be our perimeter. So I have two solutions. First involves calculus, the second one doesn't involve calculus, though they are very similar. So first I drew a rectangle, labeled as y and x. I figured out my primary equation, so it would just be the area of this rectangle, so x times y equals a. Our secondary equation would just be the perimeter, so 2x plus 2y equals p. I just substituted p with 250 because it gives us p equals 250 up here. Now we need to solve for one variable, so we get only one variable in our primary equation. So by doing that, we just solve for a variable in our secondary equation. We can solve for either x or y, but I just chose x. So x plus y equals 125, x equals 125 minus y. Now we plug x right here into a primary equation. So y times 125 minus y equals area, 125y minus y squared equals area. Now to find the maximum, we need to take the derivative of our area and set it equal to 0. So the derivative would be negative 2y plus 125, and then set it equal to 0 would be negative 2y plus 125. Y would be 62.5, and to solve for x, we just simply plug in 62.5 into our perimeter equation and solve for x. So 2 times 62.5, 125, subtract it, 250 minus 125 is 125, divided by 2, x would be equal to 62.5. Now let's analyze why these two numbers are the same. Well, it's telling us that it's a rectangle and we want to maximize the area. So the maximum area for any rectangle would be a square. And since the maximum area is a square, that means x and y have to be the same number. So this solution does make sense. Now let's move on to solution 2. So I denoted w as width and l as length so I don't get confused with x and y later on. So like this, the other solution, we need to find primary and secondary equation. Primary is a equals wl. Our secondary perimeter would be 2w plus l equals 250. Now rewrite our primary equation. So 250 equals 2w plus 2l, 250 minus 2l equals 2w, 125 minus l equals w. Solve for w, we could plug in w right here into our area equation. So it would be area equals l times 125 minus l, area equals negative l squared plus 125. Notice this is a quadratic equation. We can use quadratic properties instead of calculus to solve this problem. A equals negative 1, b equals negative 125, and c equals 0. So I drew a little graph here showing it's a downward facing parabola, so our vertex would be maximum. To find our vertex, we can use negative b over 2a to find the x value of our vertex. So to find the vertex, we just plug in 125 right here, negative 125 over 2a is negative 1. 62.5 would be the x value, and since I replaced L with X in our area equation, I know my length is 62.5. Now you can plug in the L right here, 62.5, into your perimeter equation. So 250 equals 2W plus 2 times 62.5. W would be equal to 62.5. Now there is another way to solve this using a calculator, and so you turn your calculator on first of all, and then you can plug in y equals, plug in your function, go to graph, and then you can do second calc, find your maximum, so you want to press 4, and then lower bound, and then your press enter. Got it. Maximum x equals 62.5, which would be our length, and you just plug it into your perimeter equation to find your width. And that's how you solve an optimization problem. Thanks.